As mentioned in the previous recording, work is the act of transfer of energy. If the system loses energy, the system, whatever you have, loses energy, then work is going to be negative. If we add energy to the system, then work is going to be positive. Now, examples of work that is negative is the work done by the friction force. For example, if something is moving while slowing down because of friction, then the work done by the friction force is taking energy out of the system. So it is negative work. Now, someone pushing something and getting it to move faster and faster is something that's doing positive work, adding energy to the system. Now, work does not depend on direction, other than the fact that you need to have a displacement for a force to do work. Other than that, work is a scalar quantity. Now, one key point here that you need to remember, in everything we do, not just physics, we add apples to apples, oranges to oranges, cats to cats, cows to cows, chicken to chicken. We don't mix and match. This is particularly true in physics. A vector can be added to a vector. A vector can be equal to a vector. It cannot be equal to a scalar, and vice versa. Now, when we say work is a transfer of energy, it means that a difference between two energy levels would be equal to work. An energy final minus an energy initial would be equal to work. That's the meaning of the word transfer. Now, whenever we use an equal sign, that means these quantities have to be of the same nature. One particular thing is they need to have the same units, and they need to be either both scalars or both vectors. Now, when you talk of energy, one thing to remember that it's not a vector. Remember, a vector is something that needs direction. When you buy gas, you don't worry about 10 gallons of gas south or east or whatever. 10 gallons of gas. You need only one number to describe that amount of gas. When you eat 1,000 calories or so, you don't eat 1,000 calories up, down, left or right. You eat 1,000 calories. It does not depend on the direction. It is just a one quantity. Calories. It's a scalar. The same thing for work. It's a scalar. Now, the unit that we use for work or energy, remember they are interchangeable, is joules. And if you recall what we mentioned in a previous recording, joules is newtons times meters. And that's due to the fact that work is force times displacement. Force is newtons times displacement meters. That gives us joules. One of you might ask me, and this is to clarify this because that's an important point. We don't go through this kind of math in this course, but it's just worth mentioning. When we write that work is equal to F times D, one of you would tell me, I hope, would have thought of this question before I mentioned it, but you just told me you cannot write something equal to something of a different nature. You tell me that work is a scalar, but then F is a vector. The displacement is a vector. That's absolutely right. Except here we have this product, F times D, is a special type of product is that we call scalar product. We are not going to get into that here, but in a scalar product you multiply two vectors and get a scalar. A scalar product is the product of two vectors whose result is a scalar. Okay? And that's why we can write the equal sign. Now, in more advanced, in physics courses that use more math, we use this in terms of a scalar product, and we don't speak of just F parallel, we speak just of the scalar product, and a person who knows what the scalar product would know how to account for all of that.